Gold. You know, it's the ultimate symbol of wealth, of power, of something that lasts forever. We wear it, we save it, we even go to war over it. But have you ever really, truly stopped to think about where it all comes from?
And I'm not just talking about a mine somewhere out in a desert. I mean, where in the entire universe is gold actually forged? The answer, it turns out, is way more spectacular than you could probably ever imagine.
Okay, so get this. Not a single atom of the gold you see has ever been created here on Earth. All of it. Every tiny fleck in your wedding ring, in your electronics, all of it is extraterrestrial. It is literally an alien metal that had to travel across the cosmos just to get here. So, how in the world is that even possible? Well, to understand the origin, we gotta dip into a little bit of physics. An element's identity, what makes it, is all locked into its core, specifically the number of protons in its nucleus. So hydrogen has 1, helium has 2. To make gold, you somehow have to smash 79 protons together and make them stick, and that takes an absolutely unbelievable amount of energy. Now, the universe's natural element factories, those are stars. Our very own sun, right, is basically a giant fusion engine. It spends its entire life just smashing hydrogen atoms together to create helium, and in the process, it releases all the energy that lights and warms our world. But here's the thing, our sun is just, well, it's kind of wimpy for this job. It can make helium, sure, and eventually some carbon and oxygen, but that's about as far as it can go. To keep this process rolling, you need much, much bigger stars. They can keep fusing heavier and heavier elements, but even those massive stars eventually hit a dead end. And that dead end, that cosmic stop sign, is iron. See, for a star, fusing all the elements up to iron releases energy, which is what keeps the star alive and shining. But when you try to fuse iron, it actually consumes energy. The second a star's core starts churning out iron, its engine just dies. Gravity instantly takes over, the star collapses, and, well, something even more violent has to happen to make gold. For a really long time, the prime suspect for gold's creation was the supernova, the absolutely spectacular death of one of those massive stars. When that star collapses and then rebounds in a titanic explosion, the conditions inside are just insane. Inside that fireball, a crazy thing called the R process happens. It's basically where an atomic nucleus gets bombarded with a tidal wave of neutrons. Think of it like a cosmic hot dog eating contest, where the nucleus is being force-fed neutron hot dogs so fast it can't even process them. This rapid stuffing instantly beefs up lighter elements into heavyweights like platinum, uranium, and, you guessed it, gold. And for decades, that was the story. Case closed, right? Supernovas make gold. But astronomers are, a meticulous bunch, and when they actually ran the numbers, they hit a snag. A big one. Supernovas just don't produce nearly enough gold to account for all the gold we see in our galaxy. There had to be another piece to the puzzle, a bigger, more powerful gold factory out there. And this brings us to the big plot twist. So let me introduce you to the new champion of cosmic alchemy, the kilonova. This isn't the death of one star. Oh no. This is the cataclysmic, universe-shaking collision of two of the absolute strangest objects in existence. I'm talking about neutron stars. These things are the leftover collapsed cores from a supernova. And they are incomprehensibly dense. I want you to try and imagine taking our entire sun, all of it, and crushing it down into a ball no bigger than New York City. The density is it's almost impossible to wrap your head around. A single teaspoon of neutron star stuff would weigh 1 billion tons here on Earth. So what happens when two of these cosmic monsters, after spiraling around each other for millions of years, finally slam into each other? You get a kilonova. And the difference in output is just staggering. A supernova, yeah, it produces some gold, but a kilonova, it's a gold-making machine. The collision just sprays these torrents of neutron-rich matter out into space, creating mind-boggling quantities of heavy elements. It's not just a source of gold. Scientists are now pretty sure it's the main source. And hey, we're not just guessing about this. In August of 2017, something straight out of science fiction happened. The LIGO Observatory detected gravitational waves, actual ripples in space-time itself,
coming from two neutron stars colliding 130 million light-years away. Telescopes all over the world scrambled to find the source, and when they analyzed the light from that explosion, they found it: the chemical fingerprint of heavy elements, including a massive, unmistakable signature of gold. So how much gold are we talking about? Scientists estimated that this single brief event created at least 10 Earth's masses of pure gold. Just let that sink in for a second. A lump of solid gold the size of 10 planet Earths forged in an instant and blasted out into the galaxy. So, these incredible cosmic collisions seeded the universe with gold dust. And this dust then mixed into these giant clouds of gas and other debris that eventually collapsed to form new stars and new planets, including our very own solar system. But believe it or not, that is still not the end of the story. You see, when the Earth first formed, it was just a hot, molten mess. And just like in a bottle of salad dressing, the heavy stuff sinks. Well, gold is very, very heavy. And it also loves to bond with iron. So nearly all of the Earth's original gold sank straight down to the center of the planet, where it still is today, completely out of our reach. In fact, there is so much gold locked away in the Earth's core that if you could somehow pull it all to the surface, it would cover the entire planet in a layer 1.5 feet deep. So wait, if all the original gold is down there, why do we find any of it in the crust at all? The answer, once again, came from the sky. About 200 million years after the Earth formed and its crust had hardened, the solar system went through this incredibly chaotic period. For millions of years, asteroids and comets, basically leftovers from the solar system's formation and rich with gold from those ancient kilonovas, just pummeled the young Earth. This cosmic delivery service is what salted the Earth's crust with all the gold we can actually mine today. So all of our gold is literally alien metal that fell out of the sky. For centuries, alchemists dreamed of making it themselves. What we know now is that they were basically trying to replicate a neutron star collision in a basement lab. It's kind of no wonder they failed. But can modern science do any better? Well, the answer is a hilarious yes and no. Back in 1980, scientists actually did it. They used a particle accelerator to smash other atoms into bismuth, successfully knocking off protons and transmuting it into a few atoms of gold. So alchemy is real, but it's also the single worst business model in the history of the world. The process is so wildly expensive and inefficient that making just 1 ounce would cost over $1 quadrillion. Which means, for the foreseeable future, we're pretty much stuck with what we've got. Or we have to look back to the source space. This number right here, that's the estimated value of all the metals, including gold, on a single asteroid named 16 Psyche. It's thought to be the exposed metal core of a dead planet, and humanity is already making serious plans to go there. So the next time you hold a piece of gold, I want you to remember its absolutely unbelievable journey. It was forged in the collision of dead stars. It traveled across the void for eons. It rained down on a young Earth and was then eventually dug up and shaped by human hands. It's not just a metal. It is a relic of the most violent and creative forces in the entire universe.